wanted to talk today about making coding agents actually reliable and useful. Coding agents are everywhere. You've seen that. Cloud Code, Codex, everything. Every week we've got something new. And it's becoming quite of a mess. And we see a lot of difference right now between actually people that know how to use them and the more vibe coding trend that can lead to a lot of issues. Just to introduce myself, I'm G, aka Guillaume. I'm field CTO at Upsun. We're a cloud application platform where you can deploy your web apps and everything like this. And I've been a developer for 25 years now. Crap. Started in PHP in 1998, something like this. And I followed the trend and now using daily a lot of those different coding agents and tools. So what you see online is a lot of videos okay, I've got my repo on GitHub, I'm creating a new PR, and in 10 minutes, I've got everything deployed to production working. Well, great. Except that that's not actually the case. It raises a lot of new issues and new blockers that we haven't seen before. So how do we make that a bit more reliable and efficient? And actually, the actual bottleneck is not the capabilities of the model. It's our capability of actually defining correctly the input and the output we want to have. And if you do a quick test, actually I've done that last week. I've used 4 different models, GLM, Opus, Codex, whatever. With the same input, they produce an output that is 95% the same. So the model is not the big important part. Obviously they're going to improve, they're going to get better, they're going to make less mistakes, less loops and stuff like this. That's great, but that's not the big issue. The big issue is actually what we feed into them and what we expect. Because in the end, what the model is producing is actually not really code. It's not code that works, it's actually just text. A lot of different characters that put together actually produce code and are supposed to run. So that's a quote by Andrej. Software 1 was basically what we've been doing for the last 20 years, where we really put the focus on how we want to specify stuff, all the specs, all the documentation, and how we create that. So the whole classic waterfall model. And now, with that new era of software, it's actually what we can actually verify. And the good news is that code is actually really easy to verify. If you go up on a scale, something easy to verify, for example, a Sudoku, is going to take you 5 minutes to do it, 2 minutes if you're really good, but verifying it is 10 seconds. On the other side of the thing, design, more creative work, is really hard to verify because you don't actually really know the output you want. The really good news about that is that code is highly verifiable. We know what the code should do, and we know what to expect, so we can actually test that. One of the big differences for the past 10 years is that when you're working with developers, we're humans, and we can work around gaps. I don't know, sorry, how many of you worked for clients, agencies, and stuff like this, but usually the client doesn't really know how to specify everything. The famous cahier des charges is usually 3 pages for a full e-commerce website. That doesn't make any sense. So as human, we think about that, and we implement all the missing gaps into actual feature and new specification that we roll out. But agents actually can't do that. They can't predict what the customer actually wants. So we need to actually fix all those missing parts so we can actually have agents that produce what we want. All right, so for example, if you don't have any tests, we can validate what's correct or not. If we have no spec, the agent can take wrong assumption. If you have what we call flaky build that works 30% of the time, well, it's really hard to define what's a bug in the test, maybe a production issue and stuff like this. And then observability and preview environment that actually allow you to test in real condition what you're doing and see the actual impact. If you don't have all that, you end up with that new term that we call AI slop, which is tons of code that may or may not run, we're not sure, but that has been produced by an agent, maybe not even reviewed by someone. And you don't actually know all the side effects and the edge cases. So over time, that's going to degrade your code base. So the first thing I want to talk is actually spec-driven development. I won't go into too much detail there. You can find a lot of things online. Thank you, Jerome. But basically, instead of actually just giving a prompt, waiting for the coding agent to generate something, and then like crossing fingers that everything's going to go fine, I actually start by writing specs and test. Really defining what you want the code to do, the new feature, what to do, and how to test it. And then you generate, and you validate. And then you go again if it doesn't work. So that's more like a loop, once again, define specs, try it, validate it, go back. I'm sure you've seen some stuff about Ralph Wiggum from Anthropic, which is basically that concept pushed to the max where they do like 10 different loops and then compare the output. We don't want to do that. If you have like good specs, you should end up with just one run. So once again, why it's important, we are locking the intent of what we want to do. We can review all the different change in the spec, and then we can build up our documentation and the full specification feature by feature. And we know the success criteria. That feature should allow the user to do X and stuff like this. But what I really want to talk about today is actually how we can automate verification. We want to give our agent some autonomy. The first part is testing, and as developers, we all hate tests. It's usually not part of the budget, we don't have time to do it, so we just roll out in production and hope everything's going to be great. But now with agents development, we really need to cover those tests. And unfortunately, you can't trust really the agent to generate the test right now. Because if you generate the test, in the same context as the code, all the tests are going to pass. So you need to spend some time on the test, validate all the different edge cases and everything like this. You also need to make sure the tests are running really, really fast because you want to run them a lot. If you're doing end-to-end tests with Playwright, that could take like 5-10 minutes every time you want to do something. Documentation and spec, I've already talked about that, but we want to make sure all our specifications are always up to date with the project. Code quality is super, super important. There are a lot of different standards out there. If you're using PHP, you could use PHP Stan. If you're using Node.js, you can use Biome and stuff like this, ESLint. But basically running the linters and the verification every time with some code static analysis really help, like cleaning unused code, syntax issues, and stuff like this. And what's really important is also making sure that those standards are enforced on a team level, not only yours, but making sure that all the developers in your team follow the rules from the organization. Build is super important. We all need to build our source code into production artifacts. So we need to have a build pipeline that goes fast and actually build the stuff. And if it breaks, make sure we get good debug so we can re-inject that into our agent so we can actually fix the build issue. I'm sorry, I'm really speeding up through the slides, but I will give you the link. Preview environment, and that's what we've been doing at Upsun for like 15 years now, is giving you a way to actually test in real production condition with the actual production data on a test environment. Not just the front end, but the full database, cache, queues, anything like this. So make sure you can run tests and also share that with stakeholders in a real environment that is similar to production. Observability, it's one of the big ones, but making sure that a change that has been deployed works the way you want, but doesn't have any performance side effects as well. It's really important because agents have no idea right now about the infrastructure and the behavior of your code. So you need to make sure that you actually track how that new code is performing, because it might work, but if it takes 10 seconds to generate a transaction, it's not good enough. Security, I think we've all heard about that, but making sure we don't introduce vulnerabilities with like different outdated dependencies, obvious injection and stuff like this. So having some kind of scans as well. You've got a lot of companies doing that, like Aikido, where you can actually do automated scaling of your code base every time. And standard as well, making sure you've got rules written everywhere. when I used to work in agencies 15 years ago, we were relying a lot on what I call tribal knowledge, which is like, hey, Mark, do you know how this was done 6 months ago? Yeah, sure, it was done by that guy that left. We don't want that. We want to have everything written. Our agents are guided, what they know, the context, the knowledge, everything about the project and the team should actually be documented to work. All right, just a quick recap of everything, but does it work? What should it do? Does it meet standards? Can it compile? Can it be tested? Is it working? Is it safe and consistent? That's basically my 8 different pillars. I've done a quick checklist on GitHub if you want, with like to assess yourself and your teams. So you can scan the QR, it's a GIST right there. But basically, just to make sure you're actually doing like, there are 10 criteria for each of those pillars. So if you want to actually start a new project and get the foundations right. Once you get all that, want me to go back? Too quick? All right. The important thing is the flywheel after that, where basically when you get some improvement, you get better agent production. Okay, everyone got it. So your agents are working better, they've got more autonomy, you end up with a better project infrastructure overall, and then the agents can also improve those infrastructure. So you get into a more virtuous cycle about everything. If you build the verification layer right, then the agents can actually work on their own and do some good stuff. If you want to read more about that, OpenSpec is the framework I use for actually writing the specification and stuff like this. Really good. It works with any agents. And you can follow Andrej Karpathy and Jason Way. They've done a lot of talks and written a lot about all that concept of autonomy and verification. Thank you. And because I'm trying to build my LinkedIn audience, if you want to connect, please. Thank you so much.